Hello, boys and girls. Welcome to Mrs. Bandu's Math Movies. This is for my algebra class, lesson 4-5, compound inequalities. The heading on your paper says equalities, but that's incorrect. It should say inequalities. Our objectives are to solve and graph inequalities containing and secondly, to solve and graph inequalities containing the word or. So first, let's define a compound inequality. A compound inequality is formed by two inequalities that are joined by the word and or by the word or. Okay? So basically we're putting two inequalities together and going from there. Alright, so writing a compound inequality. Write two compound inequalities that represent each situation. Graph the solutions. Okay. And basically what that means is that when we have the word and in there, we can actually write it in two different ways. That's why it's asking you to write two. So all real numbers that are at least -1 and at most 3. So there's the two situations. Numbers that are at least -1. So numbers greater than or equal to -1 and at most 3. So B is less, at most, is going to be less than or equal to 3. Okay, so this is how it can be written with the word and. You can also remove the word and write it like this. And it's written like this, but truly we read it a little bit differently. -1 is less than or equal to B, which is less than or equal to 3. Or B is greater than or equal to -1 and less than or equal to 3. Okay. Now, when we want to graph that, we do pretty much like we did before. B is greater than or equal to -1, so that's going to be a solid dot at -1, and I'm going to be shading things to the right on that to show greater than. B less than or equal to 3, I go to 3, and I'll have a solid dot at 3, and less than or equal to. So I want the and, things where these two graphs, if I extended them out independently, this is just the part where they would overlap. So you want to be sure that you have the appropriate points, open or closed, and that you clearly shade in the part of the number line that contains the solution. Okay. So it's a very definite part of the number line, not infinity as we have seen in many cases before. All real numbers that are less than 31 but greater than 25. So 31 is greater than n, and n is less than, greater than, I don't know why I said less than there, greater than 25. So we have 31 is greater than n, and n is greater than 25. Okay, so in this case, what we'll do is we look at numbers greater than 25 and numbers less than 31. So greater than 25 would go this way, less than 31 would go this way. Because it's an and statement, we want the overlapping, again, the overlapping section of the solution on the number line. Okay. All right. Solving a compound inequality containing and. So we want to solve 5 is greater than 5 minus f, and 5 minus f is greater than 2. Write the compound inequality as two inequalities joined by the word and. So that's how this has been set up for you. And we basically break it out into the two separate inequalities and can solve going from there. So in this case, we will subtract 5 from each side, which they've shown you here. 5 minus 5 is 0. which is greater than negative f. Then we're going to want to divide each side by negative 1, so we come out with f is greater than 0. Bring down my word and here. Again, we'll subtract 5 from each side. So 5 minus f minus 5 equals negative f is greater than 2 minus 5, which is negative 3. Again, we have a negative coefficient on our variable, so we're going to multiply or divide each side by negative 1. Remember, when we do that, we must reverse our inequality to maintain the truth of the inequality. Okay, so that's 3, so f is less than 3. So we end up with 0 is less than f, and f is less than 3. So basically, reading from the perspective of f is greater than 0, and f is less than 3. So again, that gives me open dots, and I'm going to be graphing the part where those two inequalities would overlap. Okay, write an inequality that represents the situation. Graph the solutions. All real numbers that are less than 0 or greater than 3. So numbers less than 0 or numbers greater than 3. Okay, this would be an or statement in here. Now, numbers that are less than 0 would give me an open dot at 0 and shade to its left. Okay, again, you want to be sure that you are clearly graphing so that one can tell what you intend your solution to be. Or n is greater than 3. So basically what happens here is we exclude part of the number line between our two numbers. Everything less than 0, everything greater than 3. And that's an or statement. With an or statement, you're usually going to have a hole in your graph. Okay, number 4. Solving a compound inequality containing or. Solve the compound inequality. 3x plus 2 is less than negative 7, or negative 4x plus 5 is less than 1, and graph the solutions. So again, we basically approach this as two separate inequalities, and then we graphed their solutions on the same number line. Okay. So 3x plus 2 is less than negative 7. I'm going to subtract 2 from each side of my inequality. Then I end up with 3x is less than negative 9. Divide each side by 3. So x is less than negative 3. Or negative 4x plus 5 is less than 1. Here I'm going to subtract 5 from each side. So negative 4x is less than negative 4. I'll divide each side by negative 4, so I will need to reverse my inequality symbol to keep the truth of the inequality correct. So x is greater than 1. So x is less than negative 3. So I'm going to graph that portion. Open dot at negative 3, shade to the left, or means there's going to be a hole in here because there's some numbers that are not going to make this true. X is greater than 1. And that would be my solution. Now you can always check your solutions by choosing a number in the shaded area, substituting back in, and it should make things true for you. Okay, you have several quick checks to complete, actually 3, but they're multi-part. So please have those completed by the next time we meet, and I look forward to seeing you then. Also bring in any questions or concerns that you have, and we will go from there.